So here, so yesterday I said some mutable methods like how to, yes. So we are talking about, so pop operation. So here we can use a list as a stack. We can use a list as a stack. Now list can be used as a stack and stack data structure can be implemented using list. And stack is a data structure or stack data structure follows last in, first out. So last in, first out means the element added last is removed what here first. So the element added last is removed first, that you call it as last in, first out. Okay. So the element added last is removed first. That is called as last in, first out. For example, if you take, okay, if you take this is a stack, but how you are representing a stack as a list, how you are representing a stack as a list here. Now this is a list which you are representing it as what? Stack. Okay, assume that this is one list. So stack uses last in, first out. In stack, the insertion and deletion is done from top end. Insertion is done from top and deletion is also done from top. Insertion is done from top and deletion is also done from top, right? For example, I want to insert 10. So this 10 will be inserted from the top. At which position? 0 position. If I want to insert 20, and 20 will be inserted from the top, in which position? 1 position. If I want to insert 30, and 30 will be inserted from the top, and this will be inserted at which position? Second position. If I try to insert 40, and this 40 will be inserted from the top, and this is inserted at which position? Third. Now this is 0, this is 1, and this is 2, and this is 3. Suppose if I want to delete 20, if I want to remove 20, first I have to remove 40 as well as what? 30. I cannot remove directly which one? 20. Because stack uses one approach. Stack uses one algorithm. What is that? Last in, first out. The element what you insert last, the element what you insert last is removed first. The element what you insert last is removed first. And that you are saying it as last in, first out, LIFO. Okay, that is called as LIFO, which is called as last in, first out. So stack allows two operations. Actually, stack allows two operations. Okay, one is a push. First operation is push and second operation is what? Pop. Within stack, you can do how many operations? Two operations. The first operation is a push and second operation is what? Pop. Now your push is nothing but adding element within stack. So push is nothing but adding element within stack, and pop is removing element from stack. So we can perform push operation. We can perform push operation using which method? Append method. So how can you add the element within the stack using append? So we can perform push operation using which method? Append method. We can perform push operation using append method. And we can perform Pop operation using which method? Pop method. Okay, we can perform push operation using append method, and we can perform pop operation using which method? Pop method. So there are so many applications. I mean, what are the applications of stack means? What are the applications of stack means? There are a lot of applications which uses stack. There are a lot of applications which uses what? Stack. If you see the applications of stack, if you see the applications of stack, so you have number of applications of using a stack. Like suppose now stack is used by which one? Compilers. Compilers or interpreters. Stack data structure used by compilers and interpreters for verifying syntax errors. For verifying syntax errors. For verifying syntax errors. And stack is used by the runtime systems for evaluation of which one? Expressions, mathematical expressions, mathematical mathematical expressions for evaluation of mathematical expressions. And stack is used for evaluation of functions. Stack is used for evaluation of which one? Functions. All these are in real time where the stack is used. In real time where the stack is used is, in real time the stacks are used while developing compilers and what? Interpreters for verifying the syntaxes. While developing compilers and interpreters for verifying which one? Syntaxes. And even stacks are used in runtime system for evaluation of what? Mathematical expressions. And even evaluation of certain functions are done by using which one? Stack. For example, if you take one expression, suppose if you take one expression like 1 plus 2, 1 plus 2 into 3, I write 1 plus 2 into 3 minus minus 5. Suppose if I write 1 plus 2 into 3 minus 5. So in this expression, how many operators are there? If you take this expression, how many operators are there? Plus a star and one more is a minus. So plus a star and one more is what here? Minus. So total 1, 2 and one more operator is what? 3. But always the evaluation of expression is done by taking the precedency of operators or not? Yes. Operator precedence. It uses what? Operator precedency. So within plus star minus, which one is first evaluated? Star. Then next and then what? Minus. But how this organization of operators are done? How the evaluation is done? Internally, it uses which one? Stack. Actually, this expression is called as which expression? Infix expression. This expression is called as which expression here? Infix expression. Infix expression. And expression is never evaluated in what? Infix. Expression is never evaluated in what? Infix. It will convert. For evaluation, it converts the expression either in prefix or what is that? Postfix. It will convert either into prefix or what? Postfix. This expression is converted into either prefix. It will convert either into a prefix or it convert either into what? Postfix. Why it will convert either into a prefix or postfix? By converting into a prefix and postfix, these operators will be organized according to what presidency. These operators are organized according to what precedence. First, you should organize it, then you should evaluate it. First, you should organize and then you should evaluate. But how it will organize and evaluate? Internally, it uses which one? Stack. So, in real time, the stack is used so many applications, right? But I've just given only 3 examples, but there are a lot of applications of which one? Stack. So, that stack you can implement in Python using which one here? List. Okay, you can implement it by using list. For example, uh, for example, for example, so I want to create a stack. So what is the name of my variable here? Stack. But how you are representing this stack? As a list. So my list is what now? Stack. Okay. So what operations you can do on the stack? Push, and one more is a pop. So push is nothing but adding or not? Yes. How you are adding the element within the stack? Append. So will it append will add the end of the stack or not? Yes. So you don't have any method called push, but there is equivalent method provided by list. And what is that equivalent method provided by list? Append. So you are trying to add 10 to the stack. You are trying to add the 22, which one? Stack. And you are trying to say stack dot append. You are trying to add 30 to the stack. You are trying to say stack dot append. You are trying to add that 40 to the stack. And you are saying stack dot append. You are trying to add 50 to what? Stack. It means if you take this is a stack now, if you take this is a stack, so what is the first element pushed inside the stack? 10. Then after that, which element is pushed inside the stack? 20. After that, which element is pushed inside the stack? 30. After that, which element is pushed inside the stack? 40. After that, which element is pushed inside the stack? 50. So what is the last element which is pushed inside the stack? 50. So last in, first out. So if I want to remove, okay, if I want to remove 40, first I have to remove which one? 50. So how can I remove this? By using an operation called which one? Pop. So pop will remove always which element? Last element. So what is the last element in the stack? 50. So this 50 is removed from the stack first. So 50 is removed. So after removing the 50, now the stack is having how many elements? 4 elements. So that is 10, 20, 30 and 40. If you want, you can see the elements of the stack. So if I'm writing print, print what is a stack? Now stack is having how many elements? 4 elements. Because 50 is deleted or not? Yes. If I'm trying to say stack dot, if I'm saying stack dot pop, which element is removed from the stack? 40. So after removing 40, now the stack is having how many elements? 3 elements. So that is 10, 20 and what? 30. So which element is removed here? Last element. Which element is removed here? Last element. Last in, first out. Right? Suppose I want to write a program. Yes. For example, I want to write a program to perform stack operations. So instead of writing in interactive mode, so I want to write a program to perform which operations? Stack operations. Write a program to perform. Write a program to perform which operations? Stack operations. Okay. Now stack is having how many operations? 2 operations. One is adding and one more is what? Removing. Adding is done using push method and append method, and removing is done by using pop method, right? So what you can do is, so I'm creating first a stack, but how you are representing a stack? You are representing a stack as what here list. How you are representing a stack? You are representing a stack as a list. How you are representing a stack? You are representing a stack as a list. You are representing a stack as what here list. And after creating a stack, I'm trying to write while true. So while true means, so how many times this loop is executed? While true means how many times it is executed? Infinite times. Because is it this condition is always what? True. This condition is always true means it is try to execute how many times? Infinite times. So while true, and then there is a first option here. So what is the first option here? Push here. Okay, now this is a stack. Okay, stack operations. I just write here stack operations. So the first one is push, and second one is what here? Pop. First one is a push, and second one is what here? Pop. And there is a third option. And what is the third option here? Display. I want to view the stack. How many elements are there? And there is a fourth option. And this fourth option is what here? Exit. So how many operations I'm doing on the stack? Push, pop, and view. Okay. So after that, I'm trying to input the option. So integer of input, enter your option. Enter your option. You are trying to input the option. You are trying to input the option. Integer of input, enter your option. Enter your option, and if option is, I can use match also. I can use match. Match, what is the option? So then case, what is the case here? 1. If it is 1, I have to do which operation? Push. So I try to input the element. So enter element to push here. Which element you want to push inside the stack? Then how can you push the element inside the stack? By using which method? Append method. So I just write here element. This is the element pushed inside. This is the element pushed inside which one? Stack. This is the element pushed inside the stack. So I try to use one method. What is the method I used here? Append. Okay, that is case 1. Then case 2 means if the option is 2. So before removing it, I need to verify is it stack is empty or not. If the length of the stack is equal to which one? 0. If the length of the stack is 0, okay, I cannot pop it if the stack is empty. So I'm finding the length of the stack first. If the length of the stack is 0, if the length of the stack is 0, I'm trying to display the message saying that stack is what here? Empty. Stack is empty, you cannot pop it. Then I'll try to pop it. Otherwise, I'll try to say stack dot pop. So this pop is a method will return one element, and that element is assigned to which variable? Element. And after that, I'm trying to print the element. Okay. So this is the element. So this is the element which is popped from this is the element which is popped from which one? Stack. So that is a case 1, and one more is a case 2. And if the option is 3, If the option is what here, 3, you have to display the stack elements. Okay, stack keys. I just display which one? Stack. Case 4. If the option is 4, I'm just writing break. Because this loop is infinite loop or not? Yes. You have to terminate the loop. How can you terminate the loop in between? You can terminate the loop in between using which statement? Break statement. See here. So first I created stack. What we did first, we created one stack, and you represented stack as what here? Listed. We created stack and stack is represented as what here? Listed. And here I've written while true means this loop is executed how many times? Infinite times. While true means how many times it execute? Infinite times. Okay. So you have to terminate. But when you are trying to terminate it, if you try to input the option what? 4. Case 4. Case 4. If the option is 4, you're terminating the loop using which statement? Break. Suppose if the option is 1, you are trying to read the element and you try to add that element within the stack. Okay. And you display the message, this element is pushed inside what? Stack. Suppose if the option is 2, you are trying to verify, is it length of the stack is what? 0. If the length of the stack is 0, means if the stack is empty, can you remove the element from the stack? No. So you try to display the message saying that this stack is what here? Empty. So otherwise, you are trying to remove the element. So pop will do how many operations? 2 operations it will do. One is read and one more is what? Remove. So first it will read the element. First it will read the element and assign to which variable? Element. After reading the element, it will remove it. So first it will read and then what it will do? Remove it. First it will read and then remove it. And after that you are displaying this is the element which is popped from which one? Stack. Right? So that is if the option is which one? 2. If the option is 3, you are just displaying which one? Stack. If the option is 4, you terminate. Suppose if you enter any other option other than this, case underscore. Underscore means what? Default. If it is a default, if you enter any other option, you are just writing invalid, option, try again. I just display the message invalid option and try again. Invalid option and try again. If the option is which one? Underscore. Underscore means if it is not equal to 1, if it is not equal to 2, if it is not equal to 3, if it is not equal to 4, if it is not equal to any one of this, then it will execute which one? Default. And default is invalid option and you get the message try again, right? So let us execute this. So these are performing which operation? Stack operation. One is for adding element. So 10 is pushed inside what here? Stack. 10 is pushed inside the stack. Again, I input the option 1 and I said 20. So 20 is pushed inside what here? Stack. Which element is there on the top of the stack now? Tell me, which element is there on the top of the stack? Which element is there? We pushed which one? 10. And then we pushed which one? 20. Which element is there on the top of the stack? 20. If I say pop, which element is removed from the stack? 20. Okay, last in, first out. So which element is removed? Is removed. If I say 2, now which element is removed? 20 is removed from the stack. So now stack is having how many elements? Only 1. Can I see the stack elements? Yes. How can I see the stack elements? By using option 3. So 3 is for displaying or not? Yes. So how many elements are there in the stack? Only only one element, and that element is what? 10. If I say 2 again, now 10 is popped from the stack. Now is this stack is empty or not? Yes. If I'm trying to pop again, it will display the message. What is that? Stack is empty. So if I enter any other option 5, so 5 is valid or invalid? Invalid. So it will execute default case and there is a message invalid option. Try again. So if I enter 4, 4 is for break. Break is for terminating the loop. Break is for terminating which one here? Loop, right? So this is how you are trying to do which operations? Stack operations. So push, pop, and one more is a view, right? But you have to understand. So there are even certain problems you solve it by using which one? Stack. I said where stack is used is these are the applications of which one? Stack. Okay, right? Now you can also implement queue. So queue implementation using list. So queue implementation using list. I can implement a data structure called queue. I can implement the data structure called queue using which one here? List. I can use a list as a queue. I can use the list as what here? Queue. So queue is a data structure. Okay, queue is a data structure. Queue is a data structure which follows first in, first out. Which follows what here? First in. Queue data structure follows first in, first out. So the element added first, the element added first, the element added first is removed. The element added first is removed first. The element added first is removed first. That is called as first in, first out. But stack is the element added last, last in, first out. But this is first in, first out. So stack allows again two operations. One is one is adding, and one more is what? Removing. So stack also allows how many operations? Two operations, but there is no specific name like push and pop. Like in stack, you are trying to use two terms like push and pop, but in queue, you don't have any terms like push and pop like that, but you'll say adding and one more is what? Removing. Okay, adding and what? Removing. So adding and removing. So now list provides the following methods to add, following methods to perform to perform queue operations. To perform queue operations. So first one is append method and second one is delete keyword. You have to use delete keyword to remove which element? First element. Now there is no separate method for deleting. For example, if it is a stack, there is a method called what? Pop. If there is a stack, there is a method called pop. Using pop, you can remove the element. Using pop, you can able to remove the element. But here you don't have any separate method for removing. So you have to use a keyword called which one? Delete. You have to use a keyword called delete. So what are the applications of queue? What are the applications of which one? Queue. What are the applications of queue? So what kind of application? I mean, where this queue is used? So the queue is used. What are the applications of queue? First in, queue uses what? First in, first out. First in, first out. First in, first out means, I said, there are certain, I said, for example, if you take undo operations, undo operation uses first in, first out or last in, first out, last in, first out. So this is an example for which one? Stack. Undo is an example for which one? Stack. So what are the applications of queue? Where it uses first in, first out. First in, first out. First in, first out applications is where it is used. For example, operating system, operating systems, operating systems or servers, operating system or servers uses which one here? Queue for processing, for processing, for processing which one? Request, for processing request or instructions, for processing request or what? Instructions. What I mean to tell you is, for example, for example, assume that if you take reservation server is that railway reservation server or any reservation server you take, there are multiple people send a request to what? Reservation server. But how reservation server will schedule all those requests? It will try to schedule by following one data structure or not? Yes. What is the data structure it uses? Queue. It means the person who sent first a request, that person request has been processed what? First. That is called as first in, first out. That is called as first in, first out. So operating systems, servers, operating systems and servers, all these internal uses like scheduling algorithms. Scheduling, certain scheduling algorithms uses which one? Queue. That is called as first in, first out. Getting on. So lot of applications are there, but this is one application of using which one? Queue. Suppose token system. Token system is there. Call centers. Call centers, which one? Token system. So token system, tokens are issued and tokens are processed in which order? Queue. That is first in, first out. Getting on. So any application in real time, it implements one data structure. Any application in real time, any application in real time implement one data structure. Any application in real time implement one data structure, and the data structure is what here? Either stack, that can be queue, that can be tree. So that can be any data structure, but you should know it. Okay, so you should know it like how to implement these various data structures. Okay. Okay, right. So all these are the applications of which one? Queue. Just try to implement or try to write a program. Write a program to perform. Write a program to perform which operations? Queue operations. Okay. Write a program to perform queue operations. So write a program to perform queue operations. So write a program to perform queue operations. So I try to represent a queue. So I'm trying to represent a queue as what here? List. So list is what now? Queue. Okay. So I try to do certain operations. So while true means, so the loop is executed how many times? Infinite times. Okay. Now this is which operations you are doing here? Queue operations. There is a first operation which is called as which one? Adding. And second operation is which one here? Remove. First operation is add, and second operation is what? Remove. And third operation is what? View. View or display the queue. And fourth operation is what here? Exit. Okay, now, so four options or three operations you are doing on which one? Queue. So I need to input the option here, integer of input, enter your option, If option is one, what I have to do? I have to add it. Okay, so element, integer of, enter element to what here? Add. Enter element to add. Enter element to add. But how you are adding the element? By using a method called append. How you are adding the element? By using a method called append. So this element is added to which one here? Q. So after that, I'm trying to display the message saying that element which one? Added. Element added. Okay, I use if. In the place of if, you can also use what? Match case. Okay, so else if option equal to what here? 2. So before removing it, I need to verify is it Q is empty or not. I need to verify is it Q is empty or not. If the length of the queue is 0, if the length of the queue is what here? 0. If the length of the queue is 0, if the length of the queue is 0, if the length of the queue is 0, then can you remove the elements from the queue? No. So this indicates that queue is what here? Empty. Queue is empty, you cannot remove it. Okay, now queue is empty and you cannot remove it. Queue is empty and you cannot remove it because length of the queue is equal to what here? 0. Length of the queue is equal to 0. So it is empty, you cannot remove it. Otherwise, you have to remove it. Which element you have to remove it? First element. Okay. Q uses what here? First in, first out. So if you take this is a Q, this is 10 and this is 20 and this is 30 and this is 40 and this is what here? 50. If you take this is one Q. Okay, now if you take this is one Q, Q follows first in, first out. Then I have to remove which element? Always first element only. I have to remove always which element? First element. Because whenever I remove the element, it will shift all the elements from right side toward left side. Suppose if I remove this 10, then this will become 20 and then 30 and this is 40 and this is what here? 50. Okay, now, so if I remove 20, then this becomes 30 and this is 40 and then what here? 50. If I remove this 30, then this becomes 40 and what is that? 50. So it means removing always which element here? First element. And the index of the first element is what? 0. Index of the first element is what? 0. So I need to write element. First I try to read the element which I am removing it. So first I try to read the element which I am removing it. Which element I am removing? First element. So I read the first element and assign to which variable? Element. So after that, I try to delete it by saying q of which one? 0. Q of 0. Q of 0 means it's trying to delete which element? First element. First element. And after that, I'm displaying the message is removed. Is removed from which one? Q. So else if option is 3. If option is 2, you are doing this. Else if option is 3, if option is 3, what you have to do, you have to display the queue. But before displaying the queue, you can also check again one more condition. If you want to list the queue, I want to find first, is it any elements are there within the queue? If the elements are there, I display the queue. If the elements are not there, I'll display queue is what? Empty. So how can I find out that if length of the queue is equal to which one? 0. Then I'm saying this queue is what here? Empty. This queue is empty. If the length of the queue is 0, this queue is empty. Otherwise, I try to display. Otherwise, I try to display the elements of which one? Queue. Okay, queue is anything you can write. Queue is what is the name of my variable? Queue. What is the name of the list here? Queue, right? So else if option is 4, break, else invalid option, invalid option, invalid option, invalid option, try again, right? So this is a message I displayed. If you input any other value other than 1, 2, 3, 4, if you enter any other value, then it will come to which block here? Else block. If you enter any other value, it comes to the else block and print the message invalid option, and try again. Invalid option and try again, right? Yes. So this is, so once you run this, so first option is add. So 10 is added, element added. First option is add, 20 is added. First option is add, 30 is added. So how many elements are added here? 3 elements. Now the stack is having how many elements now? 3 elements. So that is 10 and 20, 30. So Q follows first in, first out. So if I write here 2, so which element is removed? 10 is removed. So 10 is removed from the queue. So after removing 10, now Q is having how many values? 2 values, that is 20 and 30. Because 10 is removed, right? After removing 10, so this 20 is shifted towards which side? Left side. Okay, this 20 is shifted towards the left side, and this 30 is also shifted towards which side? Left side, right? So then next is again I'm saying 2. Which element is removed? 20 is removed. Again, if I'm saying 2, 30 is removed. If I say 2, Q is what now? Empty. So because is it any more elements in the queue? No. Getting on. So you can implement all the data structures. If you have a knowledge of data structures, you can implement each and every data structure in what? Python. Each and every data structure you can implement in Python. You can implement trees, you can implement graphs, everything you can implement in what? Python. Getting on it. But actually data structures is a separate course generally. Okay. But here you try to learn predefine data structures like list, set, that's all. Okay. But these are some other data structures which are used in real time application development, right? Okay. So this is implementation of stack, and this is the implementation of which one? Queue. Okay. Next, we'll see other methods which one? List. So in list we have seen how to add it, how to remove it, how to replace it, how to read it, and there is one more method called which one? Insert. Okay, there is a method called which one? Insert method is there. Append method, insert method. Append, what is the difference? Append and insert. Append always add the at the end of the list. And if you want to add any element in between, append means always at the end. But I want to add one element in second position. I want to add one element in what? Third position. I want to add one element in what? first position. Then how can I add the element at specific position? How can I can add the element at the specific position by using which method? Insert method. Insert method. So this is so this method is used. This method is used to add, insert or add element at given what position. If you want to add an element at given position, you are adding it by using which one here? Insert. Okay, you are adding it by using which one? Insert. So what is the syntax? What is the syntax of this insert is insert it followed by index, comma, which one? Value. Okay, insert it followed by index, comma, what is that? Value. Index, comma, value. Insert followed by index, followed by which one? Value. So this method is used to insert or add element at given position. So syntax is insert. You have to give the index, and you have to give which one? Value. So you are inserting this value at this position, right? So if the index is wrong, then it will try to append. If the index is not within the range, it will try to do what? Append, but doesn't gives any error. It doesn't gives any error, but it will try to do what? Append. So for example, I create one list. I create one list with how many values? 5 values. Okay, now list is having how many values now? 5 values. I'm saying list one dot insert. So I give the index position is what? 2. 2 means this is 0, 1, 2. So whenever you do insertion, the elements are shifted towards the right side. Whenever you do the insertion, the elements are shifted towards the right side. Okay. So I'm inserting at which place? Second place. So 0, 1, 2. But already second place 30 is there or not? Yes. So this 30, 40, 50 shifted towards which side? Right side. How many positions? One position. So at second position, I want to add one value called which one? 60. Now after insertion, you can see this is a list one having 10, 20, what? 60. So at second position, which element is there? 60 is there. Now this is a list, right? This is a list which is having 10, 20, okay, 10, 20, 30, 40, and one more value is what? 50. So 10, 20, 30, 40, and 50. So what is the index of this 0, 1, 2, and this is a 3, and this is what here? 4. Okay, 0, 1, 2, 3, and one more is what here? 4. So the value at 0 is a 10, the value at 1 is a 20, the value at 2 is a 30, the value at 3 is a 40, the value at 4 is what here? 50. Okay, now suppose if I'm trying to say list 1 dot insert 2, means I want to insert one value at which position? Second position. I want to insert one value at which position? Second. It to insert value at second position, it will shift the elements first towards which side? Right side. Right side. One position. So 50 is moved here, and 40 is moved here, and 30 is moved here, and then insert one value. And what is the value inserted here? 60. The value inserted is what here? 60. So whenever you do the insertion, it will move the elements towards which side? Right side. But using insert, you can able to insert how many values? Only one value. I'm trying to write insert minus 2 comma 80. What is minus 2? Is it minus 2 is the index or not? Yes. Minus 2 is also index. Now, this is minus 1 and this is what here? Minus 2. So it means the element is inserted at which place? Minus 2. So if I say print list 1, you can see -2. So when it is inserted at -2, is it shifted elements towards which side? Right side. So it means this becomes which one here? Actually, this becomes what here? -1, -2, and this is what? -3. This element becomes what here? -3, because whenever you insert, it will shift the elements towards which side? Right side. When it insert element at -2, is it this 40, 50 shifted towards which side? Right side. Then this 80 will be the position of what? -3. 80 will be the position of which one? -3. Suppose if I am writing list 1 dot, if I am writing list 1 dot insert, now the position is given 9. At 9, I want to insert 77. So what is the position I've given? 9. Index is a 9. So this is 0, 1, 2, 3, 4, 5, 6. What is it? Index 9 is there or not there? Not there. Index 9 is not there. What will happen? Index 9 is not there. Then what will happen? Index 9 is there or not there? Not there. Then what will happen? Append. So where will it add at the end? So where will it add at the end? At the end. Where will it add at the end? Okay. But is it given any error or append? Append. If the given index is not valid, it will do what here? Append. Getting on. Or suppose if I am writing a list 1 dot insert, list 1 dot insert -11 comma, -11 comma 66. -11 means -1, -2, -3, -4, -5, -6, -7, -8. But -11 is there? No. Then what will happen? Will it add at the right side or left side? Will it add at the right side or left side? Left side or right side? Left side, right? So print list 1. You can see the list 1. What is the value is inserted here? 66. What is the value inserted here? 66, right? Okay. So if you want to insert a value in between, if you want to insert a value in between, you can insert the value in between by using which one? Insert. So that is where you find a difference between append and insert. Append always add at the end of the list. Append always it will add at the end of the list. At the end of the list. Append always it will add at the end of the list, but insert method insert the value in between. Insert method add the value in between, right? But using insert method, you can able to insert only one value. So insert method add only insert only one value. Now this is syntax 1. So the syntax insert. Okay, this syntax. Okay, this syntax insert one value. The syntax insert how many values? Only one value. The syntax insert how many values here? Only one value. It will try to insert only one value. The syntax insert only one value. But if you want to insert multiple values, but this particular syntax insert only one value, and if you want to insert multiple values, then go for which one? Slicing. Okay, syntax 2 is there. So there is a syntax 2. Syntax 2. Syntax 2 is slicing. So you are writing your list name. List name equal to starting index colon stop index. Starting index, stop index equal to, you have to give which one? Iterable. Iterable means list. Okay. Now this syntax is used to insert multiple values. To insert multiple values are what? Elements. If you want to insert multiple values or elements, you take the help of which one? Syntax 2. If you want to insert multiple values or elements, you take the help of what here? Syntax 2. Okay, right? But here, the start index and start index and stop index must be what here? Same value. The start and stop must be what here? The starting index and stop index different value. Already we have replace. Using index, we can replace one value, and using slicing, we can replace what? More than one value. If the start index and stop index must be what here? Same. It should not be different, right? It should be what here? Same. For example, I try to create a list. I create a list using range. So this range will generate how many values? 10 values. Now I want to insert two values I want to insert at first place, 0, 1. At one place, I want to insert how many values? Two values. From 1 onwards, I want to insert how many values? Two values. Then I'll say list 1 of 1 colon 1. What I'm writing? List 1 of 1 colon 1. 1 colon 1 equal to, I want to insert some 11 and 22. 11 and 22, it will shift how many elements towards the right side? Two elements, because we inserted how many elements at second place, at 0, 1, second place, two elements. So how many positions are shifted here? Two positions. In the same way, if I'm writing list 1 of, I'm just writing 4 colon 4. So this is 0, 1, 2, 3, 4. So at fourth position, I want to insert again two elements. Okay, two elements, 99 and 88. So if I write here print list 1, so at fourth position inserted how many values? Two values. Ring on. So the starting index and ending index must be what here? Same. The starting and ending must be what? Same. If you give different, suppose if I say 4 colon 6, 4 colon 6, what will happen? Will it do insertion or replacing? Replacing. The value at 4 is replaced with 99. The value at 5 is replaced with what? 88. So because of that, you have to give the starting index and ending index is a same position. The starting index and ending index must be same position. So this is inserting multiple values. Inserting multiple values is done by using syntax 2. So this is a syntax 1 and this is a syntax 2. Inserting. So adding, append, remove, replace. There is one more method is there. That is nothing but copying, creating copy of the list. Creating copy of which one? List. Creating the copy of the list. Okay, sometimes in application development, you want to create a copy of the list so that I don't want the original list to be changed. So this is creating the copy of the list, sorry. Creating copy of the list, and you can create a copy of the list. So what will happen in application development is, what will happen in application development? You create one list. In application development, what you do is you create one list. In application development, you create one list, and I want this list to be unchanged. I want this list to be what? Unchanged. So whenever I want to do the operations, I want to do the operations on which one? Copy. I want to do the operations on which one? Copy. Then I try to create a copy of which one? List. I try to create the copy of the list. But this copying of the list can be done in two ways, right? So Python, so Python, so Python support Python support two types or two copies or two types of copies here. One is, so one is called as a shallow copy. One is called as a shallow copy and one more is called as a, so there is one more copy which is called as which one? Deep copy. Now you can create a copy of the list in using two approaches. You can create the copy of the list. You can create the copy of the list using how many approaches? Two approaches. So the first approach is called which one? Shallow copy. And second approach is called as which one? Deep copy. The first approach is called as a shallow copy and second approach is called as which one? Deep copy. So what is a shallow copy here is, so this is frequently asked question, right? Now what is the difference between shallow copy and what is that? Deep copy. And this shallow copy and deep copy is supported by iOS. It is supported by JavaScript. It is supported by Java. It is supported by C#.NET. Means if you learn in Python, in other languages, meaning is what? Same. Meaning is same. It doesn't changes, right? So there are two types of copies I said. One is shallow copy and one more is which one? Deep copy. Now you can see this is shallow copy. If you see this one, right? This is called as which copy here? Shallow copy. This is a shallow copy. This is called as a deep copy. And this is called as which one here? Shallow copy. This is a shallow copy, right? But I said no, there are two types of which one here? Copies. There are two types of copies. One is shallow and one more is a deep. But what is a shallow and deep copy? Yes. So I'm just taking this definition here. Okay, so generally, so yes, otherwise I'll write it shallow copy. So what is a shallow copy is? A shallow copy is which copy here? Reference copy. Shallow copy is which one? Reference copy. So in this approach, in this approach, okay, a new list is created. A new list is created. A new list or sequence is created. New list or sequences created by copying which one? References. Okay, in this approach, new list or sequence is created by copying references or what is that? Addresses of existing list or what is that? Sequences. Existing list or what is that? Sequences. In shallow copy, if any changes done in one list, if any changes done in one list or sequence, if any changes done in one list or sequence, that changes reflect to what? Reflect to what? Another list or what is that? Sequence. Shallow copy is a reference copy. In this approach, a new list of sequences is created by copying references or what? Addresses of existing list or sequences. Existing list objects addresses. Okay. In shallow copy, if any changes done in one list or sequence, that changes reflect to what? Another list or what? Sequence. Another list or what is that? Sequence. If any changes is done in one list, that changes will reflect to what? Another list. If changes done in one list, that changes reflect to what here? Another list. Okay, so that you can call it as which one here? Shallow copy. Shallow copy is called as a reference copy here, right? Yes. So here list provide a copy method. List provide which method here? Copy method, which return shallow copy, of which one? List. List provides a copy method. Your list did not provide which method? Copy method, and that copy method return. List provide a copy method, and that copy method return which copy here? Shallow copy. List provide copy method, and that copy method returns shallow copy of what? List. So what is the meaning of this here is, for example, I created one list. So there is a list with some 10, 20, 30. Okay, 10, 20, 30. So how many objects are there in the list? Three objects. How many objects are there here? Three objects are there, right? So this is a list created. Okay, this is a list created. So what is the name of this list here? List one. So this list one having the reference of how many objects? Three objects. This list one is having reference. Reference means address. It is having address of how many objects? Three objects. This is the first object. This is a second object. And this is what here? Third object. First object, second object, and third object. So this is 10 and this object is 20. So 10, 20, and this object is which one? 30. Okay. So this is pointing to the first object. This is pointing to the second object. And this is pointing to which one here? Third object. Okay, assume that address of this particular object is 1000. What is the address of this here? 1000. So actually this is how it is stored inside the memory. Assume that this address is what? 3000. So the first location is having the address of first object. The second location is having the address of second object. And third location is having the address of third object. Means list one is having how many objects here? Three objects. But while displaying it, is it display the addresses or values? Values. Okay. Now this is a list one. This is a memory representation, right? This is a list one. And I'm trying to say list two equal to list one dot. I'm saying list two equal to list one dot. List two equal to list one dot copy. I said list two equal to list one dot what? Copy. When I say list two equal to list one dot copy, what will it do? Okay, when I say list two equal to list one dot copy, what will it do here? It will create one more list. It will create one more list. So this is another list. What is this another list here? List two. So one more list is created. But after creating this list, what will it do? Will it copy the objects? No, it will not copy the objects, but rather than copying the objects, it will copy which one? Address. It will not copy the objects. It will copy which one? Address. It will not copy the objects. It will copy the address. It means in this case, is it list one and list two both are holding the same data or different data? Same data. Copy means same. But is it address is also what here? Same. Suppose this is the object, right? Is it integer is mutable or immutable? Immutable. Means can you do changes in integer object? No. You cannot do changes in which one? Integer object. Suppose if this list is having mutable object, if this list is having which object? Mutable object. If any changes done using list 2, that changes will reflect toward list 1. If any changes done by the list 1, that changes will reflect toward list 2. When if the list is having which object? Mutable object. When if the list is having which object? Mutable object. But if it is immutable object, the changes cannot be done, right? If it is immutable object, the changes cannot be done. If it is mutable object, so the list can do the changes in this object or not? Yes. So the changes, if you do it using list 1, the changes, if you do it by using list 1, the changes will reflect to which one here? List 2 also. If you do the changes using list 1, the changes will reflect to what here? List 2 also. Getting or not? Okay. So that is list 2 equal to list 1 dot copy. So this will create a copy of which one? List. This will create a copy of the list, right? So this will create a copy of the list. Suppose if it is mutable, but it's not created copy of the objects, is not created copy of the objects, but rather than creating copy of the objects, it is created copy of which one? References. Suppose, assume that because it is immutable, you cannot do any changes, right? For example, within the list 1, there is a list. Inside the list, one more list is there. Inside the list, another list is there. This is one more list. Inside the list is there. Inside the list, what do you have here? List. Inside the list, is it this list is mutable or immutable? Mutable. This list is mutable or immutable? Mutable. I said 30, 40. So total, how many elements are there in the list 1? 3. What is the first element? List. What is the second element? 30. What is the third element? 40. First element is 30 and second element is, first element is list, second element is 30 and third element is what? 40. So total how many elements are there? 3 elements are there. So this is the first element, this is a second element and third element. This is pointing to which one here? List. So is it first element inside the list is mutable or immutable? Mutable. Because first element is what here? List. Can I do the changes in this list or not? Yes. Suppose second element is what here? Integer. Can I do changes in this integer? No, because integer is mutable or immutable? Immutable. So third element is what here? 40. So 40 is an integer object or not? Yes. Can I do any changes in this integer object? No, because integer is what again? Immutable. So what is list 1 of 0? List. What is list 1 of 1? Integer. What is list 1 of 2? Integer. What is list 1 of 0? List. What is list 1 of 1? Integer. What is list 1 of 2? Integer. So I cannot do changes in integer. I cannot do changes in integer, but I can do changes in what? List. It means the first element which is there in the list is mutable or immutable? Mutable. But second element is immutable. Third element is immutable. Suppose I created a copy of it. I created a copy of it. List 2 equal to list 1 dot. What is this here? Copy. Then one more list is created or not? Yes. Another list is created, and this list is pointing to the same elements are different, same. This is pointing to the list, this is object, and this is what? List. For example, if I'm writing list one dot append, I said list one dot append 50. So using list one, I added one value into the list or not? Yes. If I add one value into the list, one using list one, that changes reflect to what? List two. And if I'm saying list two dot, list two dot remove, or list two dot remove, what is that? Or suppose if I'm saying list 2, delete, I just write here delete, delete list 2 of 0. List 2 of 0 is what here? List. From this list, I'm deleting which element? From this list, I'm deleting which element? First element. If I delete first element, is it shift all the elements towards which side? Left side. If I delete it using list 2, that changes will reflect to which one? List 1. If it is mutable, if the changes done using one list, that changes will reflect toward another list. If it is mutable, the changes done using one list, that changes will reflect toward another list. If it is immutable, the changes you cannot do it. Changes you cannot do it, right? If it is immutable, can you do the changes? No. Let us see this example here. If you say this is a list 1, within the list 1, I take another list with the 10, 20 and 30, 40, and list 2 equal to list 1 dot. List 1 dot what? Copy. So you can see list 1, and this is a list 2. Then I'm saying list 1 of 0. What is list 1 of 0? List. What is list 1 of 0? List. Inside the list 1 of 0, I try to add the element 50. So if you say list 1, so inside this list 1 element is added or not? Yes. But the same changes reflect to which one? List 2. The changes reflect to which one? List 2. If I'm saying delete list 1 of, delete list 1 of 0, and what is that? 0. Then if I say print list 1 deleted, print list 2. So changes done using one list. If I'm writing list 2 of 0, 0, I'm replacing it with 99. If I print list 1, changes are done, and print list 2. So in shallow copy is like mirror. Shallow copy is just like what? Mirror copy. Mirror. If any changes done, the changes will reflect both the places or not? Yes. Okay. It's just like a mirror, but here it will create a new list, right? Here it will create one new list. But I don't want that. If changes are done in one list, I don't want that changes to be done in what? Another list. If changes done in one list, I don't want that changes to be reflect toward another list. If changes done in one list, I don't want that changes to be reflect toward another list, then I'll go for which copy? Deep copy. Then I'll go for another copy, and that copy is called which one? So that particular copy is called deep copy here. So I said no, there are two types of copying the elements. One is a shallow copy and one more is a deep copy, right? So what is a deep copy here? Okay. So this is called as which copy now? This is an example. Yes, this is an example for which copy? Shallow copy. But when you can see the difference is, if the list is having, when you can see the difference, if the list contain which object? Mutable object. When you can find the difference is, if the list contain which object? Mutable object. If the list is having mutable object, if the list is having mutable object, if the list is having mutable object, getting or not? If it is having immutable object, if it is having mutable object, but if it is having immutable object, if it is having immutable object, so if any changes can be done or not done, not done. No changes can be done, right? If it is immutable object, if it is immutable objects, you cannot do, right? So there is no chance of reflecting, right? If it is immutable, if you do changes in one list, what will happen? Will it do the changes only in that list, but that will not reflect toward another list? So this effect you can see it if you add which objects inside the list? Mutable objects, but not immutable objects. So there is another copy which is called as what? Deep copy. So deep copy is also called object copy. Deep copy here. Deep copy is called object copy. So there it is called object reference copy means address. It is copying only address. Address of object of list 1 into what? List 2. Address of object of list 1 into what? List 2. But here it will create another object. It will create what? Another object and copy the object into another list. So in that case, is it sharing the same address or different address? Different address. It is sharing the same address or different address? Different address. So if you do changes in one list, the changes will not reflect to what? Another list. Because is it creating two objects or same object? Two objects. And this deep copy is implemented using one module, one predefined module called copy. There is one module is there. What is the name of that module? Copy. So list will not provide any method for doing which copy? Deep copy. List will provide method only for doing which copy? Shallow copy. So list is providing method for doing which copy? Shallow copy. But if you want to do deep copy, if you want to do which copy? Deep copy, then you have to use one module. What is that module you have to use here? Copy module. Now this copy module is provide one method called deep copy. But list will not provide any method for doing which copy? Deep copy. Okay, na? So anyway, otherwise I'll tell you tomorrow like how to work with this which copy here? Deep copy, right? So today we'll stop here and tomorrow we'll continue this, right? Thank you.